This is going to be fun. When you see where this is going, you're just going to smack your forehead and say, isn't math amazing? Okay, find the arc lengths of y equals mx plus b. Well, that's a line, right? Okay, y equals mx plus b on the interval between x1, y1 and x2, y2. Okay, fair enough. So what I'm really going to do is find the length of a line between 2 points. That sounds familiar. It is familiar. But let's use the new tools that we've been given. And let's start by finding the derivative. Okay? There you go. The derivative is m. Just m. Yay. Good. Now, I'd love to just use that m, and I think I will in a minute, but not fully. We'll have to substitute it in a minute. So we're going to go from A to B, and I begin and end. Let's see, I begin at x1, I end at x2. We're going to have a lot of random subscripts floating around here. And it's the square root of 1 plus m squared dx. Okay, a minute ago I just kind of stammered and said, well, we got the m and we're going to replace it in the da-da-da-da-da-da-da-da. Okay, well now it's time to replace that m. What is the slope between these 2 points? I'm glad you asked. That slope is y2 minus y1 over x2 minus x1. We are going to replace m with that. We're going to fill up this board, y'all. You may not have enough room. Should be all right. The integral from x1 to x2 of the square root of 1 plus all this squared. y2 minus y1 over x2 minus x1 squared, and then dx. Okay, well, how are we going to do this? I need a common denominator. That's what I really need. I need to simplify some stuff in here if I'm ever going to really take an antiderivative. So let's just continue simplifying the stuff under the radical. So we still have the integral from x1 to x2, square root of, okay, common denominator time. Our common denominator is x2 minus x1, but technically it's squared. So we're going to let the first fraction be x2 minus x1 all squared over x2 minus x1 all squared. That is 1. And then minus y2 minus y1 all squared over x2 minus x1 all squared. And then dx. Let's get that dx out from under that square root. Okay, where is this going? You'll see. You'll see. It's going to be fun. You're going to love it. Let's keep going. All right, we have one fraction, not two. So let's go ahead and make it the one fraction that it should be. Because when we're adding or subtracting fractions, we need a common denominator, which we just got. So it's the square root of all this fun stuff right here. And we have x2 minus x1 squared in the denominator, and the numerator is, now you might be tempted to multiply all these out, FOIL it, whatever you want to call it, but I'm not. I just think that's going to complicate our lives. x2 minus x1 squared minus y2 minus y1 squared, and then dx. Okay, well that's good to know. Let's keep moving. This is fun. As I look at that and I'm thinking, well, what can I square root? What can I actually deal with? What can I do? Here's what I can do, and I'm going to do it. I am going to take the square root of the denominator because I can. Now, if you're like, well, can't you take the square root of the numerator? No, not because we're subtracting them. So I can take the square root of the denominator, and if I do, I would not have x2 minus x1 squared anymore. I would just have x2 minus x1, and it would no longer be under the square root. It would come out here in front of the square root, which technically means it can go in front of the whole thing in the denominator. So my next step looks like this. 1 over x2 minus x1 just got factored out because I square rooted it. And then we have the integral from x1 to x2 of, I'm having so much fun here, y'all don't even know, x2 minus x1 squared minus y2 minus y1 squared dx. Okay, if you're trying to take the square root of that stuff, don't. Just stop. Just stop. Just don't. Here's what I am going to do. I am going to jump ahead and do an antiderivative. These are numbers. Every one of these are just plain old numbers. They just look funky because they're being represented by something else. So let's proceed with 1 over x2 minus x1. x2 minus x1. Okay, antiderivative time. And we're going to do the fundamental theorem of calculus on this thing. And it's going to take a little work. I'm going to have to erase some stuff at the top and just kind of keep the process going. Wish I had one of those whiteboards that could just roll up. Oh, and the sun is setting, coming through the blinds in the windows. You can see it. I have to be done with this problem by the time that spot reaches up to here, which will be in about 4 hours. So here we go. Not 4 hours. Maybe before that. I'm going to take the antiderivative of this. This is a constant. So the constant is the square root of x2 minus x1 squared minus y2 minus y1 squared. If I didn't say all that and instead I said 5, I just like 5. It's a good number. 5. The antiderivative of 5 is 5x. So that's what I'm about to do. I'm going to just put that x. Okay? That x from x1 to x2. And that is this. Do want to be correct, and I want to write it. Wow, the sun is setting quickly. At what rate, if the angle is approaching and the sun is, the earth is turning, it's a related rates problem. Let's focus on this instead. So x2, I was trying to make up stuff. Terrible at astronomy off the top of my head. y2 minus y1 squared. There we go, x. And what we're going to do is we're going to take x2 and plug it in here, x1, plug it in here, and we're going to subtract them. You're going to love this. Man, you're going to love this. It's going to be absolutely beautiful. Let me pause and make sure I haven't made any glaring mistakes. I have. I've made a terrible mistake. I've made a tragic mistake, and I'm not going to start this video over. Do you see what I've done? Awful. Let's fix it though. That was subtraction, which means that was addition, which means that should be 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 addition. I was so excited, I overlooked it. It's good to pause every now and then, make sure you're doing the right thing. I wasn't. Okay. Whew. Let's squeeze some work in down here and then we'll bring it up here. Bring it up top. 1 over x2 minus x1. And then all this stuff with an x2 in that place minus all this stuff with an x1 in that place. So here goes. Now that I got it right and I got the plus sign in there. So we're going to go square root of x2 minus x1 squared plus, not minus, y2 minus y1 squared x2 minus let's not. There we go. We'll do that. Minus, I don't need those parentheses there. Don't need that. Here we go. Square root of, I might want them just in case. You're like, man, pick up your mind. I wanted that x2 at the end. So x1 at the end of this one, and this will be x2 minus x1 squared plus y2 minus y1 squared. There we go. All right, this work, dropped a marker. It's okay, I don't like that marker anyway. This work is about to come up top, so I'm about to erase. Okay. Yep, that's what I'm going to do. Believe a will. Believe a will. We're almost done. Actually, I could squeeze this work in at the bottom. Let's not, though. It's too glorious to squeeze in at the bottom. Okay, here's what's happening. The sun is setting. Time's running short. We'll be done by the time it reaches the top of that. We'll be staring at that while I finish this. As I look at this, I realize that I have a greatest common factor, and that greatest common factor is this disgustingness with the square root. You know, the one that I had the sign error in that is fixed now. So I'm going to factor this out. And when I do, I have square root of x2 minus x1 squared plus y2 minus y1 squared. You know where this is going, I hope. And then when I factor it out, it just leaves me with x2 minus x1. You see it? You better see it quickly, the sun is setting. You, my friends, just used calculus to come up with the distance formula. The distance between any 2 points. This is the distance formula. Isn't that neat? I love that. I just can't press the stop button. It's just too beautiful. I have between now and I have that much space. It's great. I am fascinated, for real. I am fascinated that you can come up with the distance formula by simply using the Pythagorean theorem on 2 points and saying, well, the distance between these two is what happens when I subtract my x's, and the distance between these two is what happens when I subtract my y's, and then Pythagorean theorem is a squared plus b squared equals c squared, but to solve for that c, you'd have to square root it. Or you could use calculus. Absolutely beautiful. You get the same result either way.